Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Now that we have plenty of ways to increase Duke's health, we should add more danger for Duke to overcome. So in today's episode we're going to work on the landmines, both the stationary and bouncing kind, that explode on impact or hurt Duke on impact. We'll also take some time to look at the flamethrowers that can be found in the level. They spit flames at a regular interval that will hurt Duke when he's being roasted. And then finally we'll add these spikes. These hurt Duke when he gets poked by them. So yeah, let's go. Okay, let's add the bouncing mine. Now let's go to our level format page once again to figure out the correct tile code for the bouncing mine. So if we scroll down here and yeah, if we take a look at this row here, 3031 is the spiky round red bomb bouncing. So 3031. So let's go to our active factory and let's add the case for 3031. So let's see, we got, this should be the place. And let's create a class called like bouncing mine, XY. Create the class in the active package. And this guy extends active already with an X and a Y. Great, X and Y. Okay, let's override the update method and let's override the render method. So let's draw the associated tile. So this says it's tile 31 in anim 4, so that is tile 231 for us. 231, X and Y. And yeah, let's override the apply gravity function and not do anything because we are going to handle the gravity ourselves in the bounce. Okay, so if state get Duke collides with this, we should hurt Duke. So that is one thing. I guess we should move this into the enemies package because this is an enemy that hurts Duke. Okay, and yeah, we need to do a super.update because we're going to set some velocities. Now, the original mines, they bounce up with a nice rhythm to it. And yeah, if you take a look at the amount of frames that they bounce up and down, it's like 6 frames going up, 2 frames of hang time, and then 6 frames of going back down again, basically just reverse. So what we'll do is we'll keep track of the bouncing variable, kind of like the jump frames left for Duke. And let's increment the bouncing here. So we said that we had 2 times 6 plus 2 hang time, so that's 14 frames total. And then here what we'll just do is we will set the velocity y depending a bit on which frame they're in. So if bouncing is equals to 0, then we want to have a upwards velocity of minus 16. Else the next 4 frames we want to increment the velocity by 4 so that they will go up a bit slower. For 2 frames after that, we want to fix the velocity to minus 1, so it slows down. Then 2 frames after that again, we want to make sure the velocity y is 0 for the hang time. Then 2 frames after that, velocity should start to go down, plus 1. And after that, we just want to increment the velocity by 4. This should equal 1. All right. So 0, 4, 6, 8, 10 plus 4. So why is it complaining that condition less than 8 is always true, seeing as we percent with 14 here? So I don't really understand why IntelliJ is complaining about this, but yeah, let's run the game and see if it's indeed wrong what we're doing. So we gotta head over down the destructible bridge to find our bouncing mines. Alright, so this guy is floating up in the air, so we did indeed do something terribly wrong. Alright, now let's take a look here. Bouncing, if that's exactly 0, then set the velocity to minus 16. Alright, I've flipped over this. It has to check if it's less than. Alright. So let's see if we've managed to do so, to do it correctly, I mean. We should see some mines bouncing in place now. Here's one. Okay, this guy hurts. And the bullets pass straight through this mine. So I think mines can be shot, but I don't think they actually do anything when they're shot. So can be shot, return true. Alright, that's it then. They hurt us, they bounce. I think that's all there is to it. So let's take a second to also implement the stationary mine, which also extends the active tile. Let's make a public constructor for it. Super XY, and let's do the render method. So renderer draw tile assets get anim 231 it was, X and Y. And then let's have an update method that says, like, if state get Duke collides with this, then we want to detonate. So what we want to do is state spawn a new explosion at our XY coordinate. Can be shot, should be true for us as well. And yeah, I'm not sure, maybe if these are hit that they spawn sparks, but let's not do that for now. And let's set active to false so that we despawn. Okay, let's go here and let's find the stationary mine. So let's see. Here, stationary explodes on touch. It's 3057. So let's go to our active factory and add 3057 as well. So this is a regular mine, not of the bouncing type. And the stationary mine is not actually present in level 1. So what we'll do for now is in this active factory where we do the bouncing mine, let's do a temporary stationary mine here. And let's run the game. And just see if it works. Now, stationary mines are affected by gravity. So, okay, so there's a mine, and if we step on it, it blows up. So, yeah, that works. So that is the mines in this game. So let's revert this back to a bouncing mine, and let's have the stationary mine. Let's double check. Yeah, so here let's just do a super dot update as well to make sure that gravity is applied for this guy. And yeah, I think that's all there is to it. Okay, let's do the flamethrowers next. Let's go to our level format again and figure out which of the tile IDs are the flamethrowers. So here we go, we have 3009 and 3000A, flamethrower firing to the right and then to the left. Alright, object 0 starting at tile index 24 to 28. Alright, so yeah, let's go to our active package and let's start adding this flamethrower class. And yeah, it's an active tile, of course. So let's create a constructor. And so we saw that we had a facing, either left or right. So let's add the facing as a constructor parameter. And then let's have an update method. And then let's have a render method. Yeah, a flamethrower has 3 stages basically. An idle stage where it does nothing. Then it has a stage where it's igniting the flame. You can see like the little flames start to flicker. And then it has a stage where it's just burning until it stops and goes back to idle again. So let's keep a timer that controls this whole cycle. Private int timer. And then here in the update method, let's just add the timer. Timer equals timer plus 1. And then we have some sort of a duration. Final int duration is, I don't know, let's take 60 at the moment. % duration, so let's make sure we don't exceed the duration. And the width is 3 times the tile size because we're going to be placing 3 tiles for the flame. And this will be relevant for collision detection with Duke when it's burning. So yeah, let's see. So the flamethrowers in Duke, they are idle for, let's say, 32 frames. So that's 2 seconds basically. And then they will ignite. So let's say ignition starts at 32. They ignite for, let's say, 10 frames and then will burn. So that's 32 plus 10 is 42. So we'll at timer 42 will start to burn. And the full duration, let's do 20 cycles. So let's set it to 62. All right. Yeah, so here in the update method, what we should do is we should check if we're burning. So let's keep a boolean. Private boolean is burning. That says if the timer is larger than or equal to the burn timer. So once we're at timer 42 or higher, then we're considering to be burning. So then we'll say like, okay, if we are burning and the state Duke collides with this, then we'll say state get Duke.hurt. So then now we'll get hurt by the flames. But this will pose a problem for the left-facing flamethrower because of how our coordinate systems work. So we need to calculate a different X position for our hitbox. So let's just make an origin X. It says if we are facing to the right, then we want our X to be subtracted by 2 tiles because our flame goes 3 tiles to the left, but the placement tile is already at the X position, so we need to subtract 2 times the tile size. And facing left, I mean, sorry. So if we're facing right, then our X origin is fine. So this should be the origin X. So let's change this collision to say origin X with Y width and height. So this should do collision detection with Duke and hurt him when we're burning. So that is okay. So then all that we have left is to implement the actual graphics. So let's also keep a is igniting boolean. Is igniting. And this is when the timer is greater than the ignition timer, but it has to be less than the burn timer. So timer is less than burn. Alright, so rendering when the flamethrower is idle is pretty simple because we don't have to render anything, it's just not there. And for the other flames, let's take a look how this is organized here. So this is the ignition spark, and this is the ignition spark as well. And we said that in the file format it's going to be sprite 24 and 29. Alright, so that is 24 or 29. Oh, it's the wrong editor here. So if we are igniting, then we'll just say renderer, draw tile, assets, get object 24. So if we are, let's say int tile index is our facing right, it's 24, otherwise 29. Then let's grab it and X and Y. Alright, so this should display the ignition graphic. Else, if we are burning, then we need to draw this elaborate flame. So let's grab the base tile index here as well. So if we are facing right, then we want to start 1 tile later, because the burn graphics are 1 tile over. So once again, these are the ignition frames, but then here we have the flaming frames. So 2 here and 2 for the tip. So that tells me that we need to render draw tile, assets, get object, tile index, get object, tile index plus the timer %2, X and Y. So we're going to have 2 tiles with a full flame. No, I'm missing a parentheses here. So the second one will be tile index plus the timer +1. So basically we just want to see the next frame in the animation, and then the %2 will make sure we're in the correct animation tile. And here we need to offset X by tile size. And then we need to draw the tip of the flame. So that is tile index +2 plus just a regular timer %2. So that we draw an alternating tip to the flame, and here we need to increase it by 2 times the tile size. Now this is of course for a right-facing flamethrower. For a left-facing flamethrower we need to move over to the left instead of to the right. So let's just do a int delta x, and then let's say if we are facing to the right, it's going to be tile size, and otherwise it's going to be negative tile size. And then let's just refer to delta x here. Okay, so that should be the behavior and the draw code for a flamethrower. So let's go to our active factory and add the flamethrowers. So we said that we had tile codes 9 and A, 3009, 3000A. So that is here. Case 3009, new flamethrower, XY facing to the right. And then the A variant is facing to the left. And sadly, we need to change our copy code as well, where we're copying the tiles here. Because a flamethrower that is facing left will need to copy the tile to the left, which is just default right here, so that's fine. But for 3009, we need to copy over the tile to the right, because that is a right-facing flamethrower, so otherwise it will copy its own origin tile. So this should fix that tile copying. Alright, so let's take a look if our flamethrowers actually function. So we'll run over to the underground area once again, where hopefully these flamethrowers should be flaming. And here they are. So let's take a look at, we can see both. Alright, so I messed up the ignition graphic, but that's fine. It just needs to blink every other frame. Okay, so let's see if the collision detection works. So here I get hurt. Now I don't get hurt. And I still get hurt. And let's check the other side as well. Yeah, that seems to work fine. Alright, so let's fix the blinking flamethrower. So here we need to check if we are igniting, and we need to have our timer to be only the even frames. And that should do it. Yeah, let's implement the spikes next, because they are located right next to the flamethrower, so we can check out the blinking of that animation. So spikes is a new active class, as always. Extends active. Create a constructor. We have some sort of update we need to do, and we need to draw something. Let's go over to our level format here, and let's find the spikes. These are the brown spikes. These are not the spikes we're looking for. Here we have our spikes poking up and poking down, 58 and 59. And the sprites are located in object 2 and 48, 49. So that's 148 and 149 for us, poking up and down. So we have some sort of a direction, so private boolean up. And let's add that to the constructor. And then here we can say int tile index is up 148, otherwise 149. Render a draw tile object tile index x, y. And then in the update method, all we have to do is say like, all right, if we collide with Duke, if state Duke collides with this, then we need to hurt Duke because we are poking his feet. Okay, so yeah, then I guess we just need to add these spikes to the active factory. So we had 58 and 59. So 58 is the spikes that are poking up. All right, so new spikes up. and 59 is poking down. Alright, so the only thing left to do now is fixing the tile copying. Now, if we have something that is facing up, and Duke needs to be able to step on it, then it's reasonable to assume that the tile above it should be free. So let's copy over that tile. So for 3058, the upwards facing spike, let's copy the tile that is directly above it. So let's subtract the level width. So that gives us the tile that is above this spike. And for the facing down, it's reasonable to assume that the tile directly below it is free. So let's copy over that one. Okay, now let's load the level, let's find some spikes, and let's see if our flamethrowers are igniting properly as well. So we'll just head over to the flamethrowers, because there are some spikes there as well that you need to be careful not to step into when you're picking up the D-U-K-E letters. So we're almost there. Alright, so let's take a look at these flamethrowers. Beautiful. Okay, there we got some spikes. These are facing up and they hurt us. Awesome. And there we have downwards poking spikes. And those naturally hurt us as well. Alright. So those are the spikes and the flamethrowers and the bouncing mines and the stationary mines as well. So yeah, we've added a lot of danger for Duke to contend with once again. So for next episode, I think we will implement the most dangerous tech bot so far, which is going to be the jumping one. So this guy here. I think it's going to be our most complex robot so far, because he's going to follow us around, jumping, shooting. I think he takes multiple shots to kill, like this robot here. And yeah, we need to figure out the behavior when he jumps, when he shoots, all this stuff. So it's going to be a fun one. Hope to see you then. If you have any questions, feel free to put them in the comments down below. And if you like the series, then hopefully I can see a like and a subscribe being added to the count. It would mean a lot to me. Thanks for joining, and see you guys next time.